Common chemistry questions. Okay. Question number 1 says what? Which of the elements E, F, G, and H with 1, 2, 3, and 7 valence electron respectively is possibly not a metal? You know, we're given 4 elements here, and for the first element E, it has a valency of what? 1. For the second element F, it has a valency of what? 2. For the third element G, it has a valency of what? 3. While the last one H, it has a valency of what? 7. Then we have to determine, that is, we have to look for the one that is not a metal among them. You see, any element that has a valency of 1 is the same thing as what? Group 1 element. That is group 1 element. For example, now looking at sodium. You know, sodium, it has what? 2, 8, what? 1. The last one here is the valency, right? That is, I can also rewrite it like this in terms of orbital. The first orbital is what? 2. The second one is what? 8. Why the last one we take what? 1. So the last one here is what? So sodium is a metal. As you all know that sodium is a metal. So likewise, which element that has a valency of 2? E.g. calcium. You know, calcium has a valency of what? 2. That is, I can say calcium 2 plus. This one has a valency of 1. Why calcium has a valency of 2? That is 2, 8. What? 2, 8. 2, 8. 8. 2, 8, 8, 2. Okay. So calcium has a valency of 2. Why? Which element that has a valency of 3? Like aluminium. Aluminium has a valency of 3. So all these 3 elements that have valency of 1, 2, and 3, except hydrogen. Although hydrogen has a valency of 1, but as we all know that hydrogen is not a metal, but just for convenience sake, it was placed in group 1 for convenience sake. But all other elements that have a valency of 1, valency of 2, and valency of 3, they are all metals. So the only one that is not metal is what? This 7. That is our H. Why? Which element that has a valency of 7? E.g. chlorine. Chlorine. You can see 2, 8, 8. Sorry, 287. 287. Chlorine has what? 287. It has atomic number of what? 17. 2 plus 8, that is what? 10 plus 7. So 287. So is chlorine a metal? No, it's not a metal. So chlorine is not a metal. That is, this one that has a valency of 7 is not a metal. And which element is that? That is our H. The correct answer here is option B. So let's look at question number 2. Question number 2 said, which of the following electronic configuration respects the ground state of nitrogen? Okay, you know, we have different orbitals. We have s orbital, we have p orbitals. You know, for s orbital, for nitrogen, okay, I would like to write it out first. Let's write out nitrogen. Nitrogen, it has atomic number of what? 7. So it has atomic number of 7. And what is electronic configuration of nitrogen? Electronic configuration of nitrogen is what? You know, 1s2, 2s2, and 2p what? 2p3. So this electronic configuration of nitrogen. Now, for the s orbital, we have how many orbitals there? We have s orbital, we have 1s orbital, we have 2s orbital, and we have 2p orbital. Okay, for the s orbital, the maximum electron x can accommodate is what? Is just 2. That is the maximum. So, which will be what? Which will be, you can write it like this. You can write it like this. The maximum orbital for s is what? Is 2. This is for the first s. That is, the second one now is ts, right? So it can only accommodate what? 2 as well. 2. As right is s. The maximum electron it can accommodate is what? Is 2. Why for p orbital? P orbital is divided into what? Into 3. 1, 2. We have the px, the py, and the what? And the pz orbital. Okay. So this we are to share these 3 electrons into these 3, and we know that each of them accommodate what? 2, 2, 2. But according to Hund's rule, it says that electron must enter singly first. That is, electron must enter one by one first. We must put it one by one before we do what? Pair. So we must put it one by one before we do what? Before we pair. Now, if you look at this one now, this one started pairing from the first one. No, they must enter singly first, according to Hund's rule. According to application of what? Hund's rule. Okay. So this one, so p orbital has how many electrons? It has 3. So we put the 3 enter singly first, enter singly, or you can decide to put it down or up. It's still the same. Single first, single first. So they must enter singly first before we start pairing. The reason why we pair this one immediately was because for s orbital it can accommodate what? 2. This second this second s orbital as well, it can accommodate what? 2, but p can accommodate what? 6. It can accommodate 6. So that is why we divide this p into 3. You can see the first one can take 2, second one will take 2, third one will take 2. But we have to put it single first before we do what? Before we started pairing, putting the 2. But now we see that when we the maximum is what? 3. So we have already put all the 3s, nothing left again. Okay, nothing left again. So this one coming down, you can decide to put it down, you can decide to put it up, it's still the same thing. So this one you can see it puts 2 here first before putting the remaining one here. No, that's not what Hund's rule tells us. It asks us that it must go singly first before you started pairing. So this one is wrong, this one is wrong, this one is wrong. So the correct answer there is option D. Option D is the correct answer to that. Okay, so stay tuned for more tutorial videos. Consider to subscribe, like, and what? And comment. Share to your loved ones as well. See you in my next video. Thank you.